In section 6.8, we're talking about probability. Calculus plays a role in the analysis of random behavior. Suppose we consider the cholesterol level of a person chosen at random from a certain age group, or the height of an adult female chosen at random, or the lifetime of a randomly chosen battery of a certain type. Such quantities are called continuous random variables because their values actually range over an interval of real numbers, although they might be measured or recorded only to the nearest integer. We might want to know the probability that a blood cholesterol level is greater than 250, or the probability that the height of an adult female is between 60 and 70 inches, or the probability that the battery we are buying lasts between 100 and 200 hours. If X represents the lifetime of that type of battery, we denote this last probability as follows, where the probability that X is in between 100 and 200 inclusive. According to the frequency interpretation of probability, this number is the long-run proportion of all batteries of the specified type whose lifetimes are between 100 and 200 hours. Since it represents a proportion, the probability naturally falls between 0 and 1. Every continuous random variable X has a probability density function f. This means the probability that X lies between A and B is found by integrating f from A to B. So find the probability that X is in between A and B is taking the integral from A to B of that function dx. So for example, if we look at figure 1, it shows the graph of a model for the probability density function f for a random variable X defined to be the height in inches of an adult female in the United States. The probability that the height of a woman chosen at random from this population is between 60 and 70 inches is equal to the area under the graph of f from 60 to 70. So what it's saying here is that everything that's shaded here is the area is equal to the probability that the height of a woman is between 60 and 70 inches. Now in general, the probability density function f of a random variable x satisfies the condition f of x is greater than or equal to 0 for all x. And because probabilities are measured on a scale from 0 to 1, it follows that the integral that goes from negative infinity to infinity of the function dx is equal to 1.